25, 25, 25. Alrighty. Five, 20. Alrighty. So while we're waiting, we can as I said, it's gonna be a soft start today. We won't go in the AP classroom today. We'll just do what's in Canvas and watch a video and then get started on the heavy stuff tomorrow, maybe. Alrighty. Still missing a couple of people, but I got enough people to go ahead and get started. Again, welcome, welcome. So we're going to be in the unit for populations. Okay. I want to take a few minutes to look at the population overview. Now, the video that is in this section really gives you a whole overview of the unit. So, and it is 17 minutes long, and it's going to take you through each section. So I'd rather you just kind of read through the learning objectives, look at the vocabulary, and then we're going to take 3.1 and maybe 3.2, and just kind of watch the videos and then take some notes today. All right, folks, still coming in. Good, good, good. All right. Looks like almost everybody's here. Again, if you just joined, welcome, welcome. Happy New Year. So we're in Canvas and we're in the unit for populations. So look at that. Let me check to make sure that I have this published for you. Okay. All right. So what I was saying earlier is there is an introduction video and it is about 17 minutes long. And she's just basically going to go through all of kind of do an overview of.
Hey students, so glad to see you back again.
Oops.
Now we're going to talk about the populations module.
See if I can stop her. All right, and then what I also need to do is make sure I have my sound on. So I might have to stop sharing for a minute to put the sound on. But everybody should be in Canvas and the populations unit. No, I don't have it. Okay. All righty. All right, so again, you can look at this video at your leisure. Like I said, she's going to give you an overview, not just of the first unit, but she's going to go through the whole unit. So basically, she's explaining what the learning objectives are. So what we're going to look at today is just the first one. We're going to look at identifying generalist and specialist species. But we're going to look at different types of populations. There's some graphing with this unit, a little bit of mathing with the equations, but basically looking at the demographics of a populations, how they change, why they change, in terms, vocabulary terms of carrying capacity is important. So these are the vocabulary words that we're going to look at. And like I said, for today, we're going to look at the first one, generalist and specialist populations. And then we'll work all the rest of these topics in. And as always, We will eventually get, probably by Friday, get to the AP classroom, and I'll assign 3.1 and 2 by Friday. But for now, we're just gonna, take a mild come back to school day and just look at the first topic. Here we go. Okay, and so these are your key terms. If you're the type who wants to print out, there's a lot of ooh, this list is very long. A lot of key terms. I always recommend that you look through them, because it gives you, like I said, as we do graphing and things of that nature, it helps to understand what the term means if you are trying to answer a question. And that goes for the exam too. When you get ready to do the AP exam, knowing your vocabulary helps you. They like for you to use your vocabulary, and knowing what the words mean help you to write a better sentence or paragraph. So definitely, at some point, I know we don't exactly say homework, but homework, you should review these vocabulary as we go along. Okay. All right. That being said, again, we're going to do the first one, generalist and specialist. So we're going to be looking at 3.1. So let me make sure that you see what I'm seeing. And what I did not get a chance to do over the break was all right, so that's what I need you to see. And let's make it big. All right, I did upload this video to the playlist, so if it'll be available for you to look at again at a later date if you need to.
Welcome back, friends. Here we are, Unit 3. We have finally reached the third unit in the AP Environmental Science curriculum. 3.1, lesson 3.1 is all about generalist and specialist species. I know I've made reference to these earlier with some other previous lessons, but now I'm going to take the entire lesson just to focus in on the difference between these two different types of species. According to the College Board says that we should be able to identify the differences between generalist and specialist species. Identify, not that detailed level, which is probably going to be perfectly fine for a little quick lesson here. So first thing we want to define is the concept of what is an ecological niche. An ecological niche is the role an organism serves within an ecosystem.
Oops. I was just trying to pause it. Okay. All right. I do recommend that you take notes. An ecological niche is definitely a vocabulary word, and it is a term that you need to completely understand as a part of what is the role of the organisms in that population. It is their niche. So different things are going on in the population, but what the organisms are doing in that population is their individual niche. So definitely make sure that you understand this as a vocabulary word. And sometimes me pausing it makes it do wacky things.
Niche is the role an organism serves within an ecosystem. So how does it obtain its food, water, shelter, how it survives, how it reproduces, kind of what it does within the ecosystem. It's not necessarily where it lives. That's not its niche. It's a lot more complicated than that. And that's when we go back to talking about food chains, food webs, pulling something out, finding unintended consequences of the removal of the species, or the way in which species interact, and learning more about it. It's oftentimes we're finding the organismal niche is far deeper and far more complicated than we originally thought. The big thing when we talk about different species and the way in which they've evolved is their niche has really evolved to avoid competition. Remember, we talked about competition being detrimental to both species involved. It's an expenditure of energy, which they do not need to do. The goal is to conserve energy and then to be able to use that energy for reproduction and to continue to grow and develop, not to have to get your food, not to have to get all the things that you need as limiting factors. So conserving energy is really important, and niche diversity is incredibly important within an ecosystem because that's how organisms have evolved to minimize competition. So what are some examples of roles within an ecosystem? And that's kind of where we get to the title of this lesson, the idea of you being a generalist or you being a specialist. Now, when we talk about generalists and specialists, oftentimes you'll hear it applied to many different other professions or other things like that. A general contractor will be able to do everything from the roof to the plumbing. Now, there are specialists, they specialize just a plumber or specialize just a roofer, but the general contractor is usually just a handyman. They can do all these repairs. Now, are they the best at doing any one of those things? No, but you might not get the best plumber either. So it's just an idea, it's a different way. Now, each of them have their own roles. Now, certain people might get more work doing certain other projects than, a plumber, but it's the idea now when you apply those concepts of generalists and specialists to ecology and to an ecosystem, you're going to have organisms which are going to be able to experience a general lifestyle versus a specialized lifestyle. So let's go and delve into those generalists first. A generalist is we're going to put that general descriptor in front of most of these things here. They're able to be non-specific in their food selection, so they can take a general or a broad type of food. They tolerate a wide variety or generalized variety of climatic conditions. They can use a lot of different resources within their life cycle. So they're using a whole bunch of different things, so missing one doesn't cause them to die off at all. They have a broad ecological niche that encompasses many different other facets, and they can easily become invasive species, which we talked about in lesson 9.8. So the invasive species, remember, you're in a new area, so why are you able to thrive in a new area? It's because you're used to being able to adapt to a wide variety of things. Some example species, sometimes example species help you to really understand things. Things like raccoons. Raccoons are found all over the United States, constantly eating out of your trash or fish or different things like that. Whole bunch of different food sources, wide variety of habitats, wide variety of temperature swings that they can deal with. Talk about coyotes. Coyotes are other general species. Again, all the way from the deserts to the forest, they survive. And then rats, which we know can be found pretty much in any habitat, coexisting with humans or not. Now, next we're going to look at specialist species. Specialist species are very specialized in their food. They're very specialized in their habitat. They're very specialized in their way of life. So it's really understanding pretty much the opposites of everything I just talked about. They have a very specialized ecological niche. Again, let's put some examples to it. Koala bears. Koala bears are very specialized species. Giant panda, which also is an endangered species, probably due to it being so specialized. And then down here we have what's called the marvelous spatule tail. It's a variety of bird, but it's got very large plumes. It's found in very, very limited region in the Amazon or in Peru, where it's found, a very, very small geographical region. So much like we talk about general species can become invasive very easily, on the converse, specialist species can oftentimes become endangered very easily.
All right, while it's buffering, are there any questions? Right, so I'm gonna pause it there for a minute. All right, so basically you have a broad term of ecological niche, and that's where the organism does what the organism does. It's the role it plays, the job it performs, where it lives. Okay, and then there are different organisms that live in that particular ecosystem. Some live in the top of the tree, some live at the bottom of the tree, some live in the lake, but they're all in the same community, and they all have a different job. Some of them, like he's saying, are specialized. I mean, generalized, so they can live in any section and thrive. And when changes occur in one food source, they can easily switch to another food source. Specialists are they only eat one kind of things, they only like one kind of climate. They are very specific in what they need and what they will do in a particular situation. So those are the two headings that we're looking at. All right, let's let him finish.
Now let's apply the ideas of generalists and specialists to looking at climatic conditions, especially with climate change being a big thing, and talking about how these species have learned or can adapt to a changing environment. Specialists are not going to change that well. Maybe it's because their food is specialized. Maybe it's because the habitat in which they grow is specialized. When it starts to change, plants, animals, they don't move that fast. And with biomes migrating and different things, more extreme weather events, all of these things are going to put more and more pressure on our specialist species to survive. Our general species, however, are going to be better adapted to surviving within that new environment. Now, here's the thing. When we look at climate change and how it's going to impact things on the long-term scale, it's going to decrease our biodiversity levels on the planet. All right, climate change is going to cause species to go extinct. Now, why do we even have specialist species on the planet? It's because they become so unique in their specific niche that they're avoiding those type of different competitions we talked about with partitioning. Now, with climate change, you're kind of negating the uniqueness and you're forcing everyone into more of a survival mode, and that's where your generalist will oftentimes thrive. This chart is often used to represent generalist and specialist species. So I just want to kind of quickly go over it, and then I'm going to recap this lesson. So we are pretty much at the end of this lesson. The lines that you see are the two different individuals. So the panda is represented with a red line, and the raccoon is represented with a blue line. Now, the niche, or the role, the different foods, all that encompassing thing, is the area underneath the curve. And you can see with the giant panda, it's very, very small because it has a very specialized niche. It's a specialized species. Compare that with the raccoon, which has a very, very broad base to its curve, and that's because it can survive in a wide variety of habitats. Does it thrive in all of them? No. Okay, we go back to ecological tolerance. It can survive. It doesn't necessarily always mean it's going to thrive. So that is something I want to make sure you understand. Recapping this concept, specialist species, very specialized in their habitat, very specialized in their food source, very specialized in their niche, very, very likely to go endangered, under threats and duress. Compare that to a general species, which lives in a wide variety of habitats, wide variety of food, wide variety of climatic conditions, right? And not only that, but a general species can also oftentimes become invasive, because if it's introduced to a new area, it can outcompete a lot of those native specialized species in that new area. So it's something I want to make sure you can identify the differences and the key characteristics between a generalist and a specialist. If you can, fantastic. I look forward to you at the next lesson. If you can't, shoot me an email. You know how to get a hold of me. And then we'll talk about ways in which you can where we can work together to make sure you understand this topic. Thanks for tuning in. I know it's a lot shorter than some of the previous lessons we've had. Hopefully I'll keep them short for a little while, but no promises. And I look forward to seeing you at the next lesson.
You like that lesson? I know you did. So why don't you go ahead and smash that like button right now?
Okay, but we're not going to worry about him doing that. All right. Any questions? Any questions? So like he said, you need to be able to distinguish the difference between a specialized species, and if when put in the environment, which one is going to survive better than the other, a specialized or a generalist? All right, so what I need you to do in your canvas is to come to past the overview and come to this one and go through. I think I remember going through an example similar to this, but go through and look at these examples of generalists first and then specialists. Then we'll have a little quiz for you. So take, let's see, the next 10 minutes to, so we're in Canvas. We're in topic 3.1, generalists versus specialists. And you're going to go through each of these. So you're going to look at the pictures, read what's underneath. They give you examples. They talk about why they're generalists, what makes them generalists, and then do the same thing with the specialists. So look at the picture, read what's under the caption underneath, and um, understand why these examples are specialized for whatever it is, for whatever environment that they're in. Okay. All right. So next 15 minutes, let's say, you all do that. And I'm going to stop sharing. I'm going to do attendance. All right, everybody should be in Canvas looking at those examples. See some folks in other places. Because I do have a quiz for you in a little while. Isadora, are you with us? Okay, everybody had a chance to go through. Okay, excellent, excellent. All right, so someone just asked, what is the next task? I'm about to tell you what is the next task. All right, so I'm going to send you a link. So go to joinmyquiz.com. I have a little 10 question activity for you to do. And then when we finish this, I'm going to put this in the chat. All right, so the code is in the chat both ways. So this, the entire link for joinmyquiz.com is in the chat. All right, so I need everybody. If you were taking a nap, come back. All right. So I am waiting to see everybody. Thank you, Sadie. You're first. All right, so as soon as I got everybody logged in, okay, there it is. I'll go ahead and get it started. This is just 10 questions, so this is not going to take long. And when we finish this, we're going to do 3.2. So this activity is just on generalists and specialists. All right, so I should have 11 people registered, and I only have 6. This is for a grade. So everybody please participate. Who am I missing? Missing 2 people. I'm going to start in a minute. So if you're missing and you're not logged in, that's on you. Okay, but everybody needs to be logged in. All right, there's 10. Still missing 1, but I'm going to go ahead and get started. All right, so again, there are 10 questions. There we go. All right. All right, so when you finish that, go ahead and go back to Canvas and look at 3.2. Let me make sure that that module is. And we'll go straight into that one when you're done. Okay, it's published. All right, it is published. So go ahead and look at the next one. Okay, some of you haven't started. All right, please everybody start so that we're not spending all our time on this so that we can go on to the next, to the 3.2. Again, I need everybody doing the quizzes assignment so that we can all finish in a timely fashion. Ethan, I'm looking at your thing now. Okay. I give you credit for that one. All right, somebody's logged back in as test student and you can't do that. So I'm gonna have to take test student out because I don't know who that is. But test student is about to be eliminated. You can only log in once, folks. I see some people are using their notes, going back and forth to Canvas, and that's okay. And again, if you finish this quiz before everybody else does, look at the 3.2 R versus K species and read that over. That's a little bit longer, so we're going to do that next. And Ethan, I did make a note of that. I have to wait till everybody's finished to see what it did. Yes, Sadie. Okay, I'm not trying to rush you, but we could finish in the next 5 minutes. That would be nice. All right, I'm gonna give this another minute and then I'm gonna close it out. All right, when you're done, look at 3.2. It's the next Canvas unit on um, K versus R selected species. We want to try to at least get that introduced before tomorrow. Okay, so I'm going to go ahead and end this one. Uh-oh, she got logged out. Okay, so we are going to talk about this because while we got top 3 scores, 80% was the best of the top 3 scores. So we're going to have a little chat about this, but we will visit this one again probably tomorrow. But what I do want to do is go ahead and um, at least look at the video for 3.2. So let's do get him to pause for a minute while I load it up, and then we'll review both of these tomorrow. And I'll go over those questions again with you. Like I said, the top score on that was 80%. So we're going to look at that again. All right. All right. So this is on the section that follows 3.2. And we probably just only have a chance to look at this one, probably not able to.
Hey everybody, welcome back. Here we are with another lesson in AP Environmental Science curriculum. This one is Unit 3, Lesson number 2, K-selected and R-selected species. Now we talked about R-selected species very briefly when we discussed invasive species, but with this lesson we're going to go in depth talking about the differences between K-selected and R-selected species. Now, the one thing about this is that it is not that long of a lesson. I think the next couple are not that long. There is one larger lesson in Unit 3, but for the most part, they're a bunch of short lessons. So without further ado, let's figure out what the College Board wants us to know. Now, the College Board wants you to be able to identify differences between K-selected and R-selected species. Now, and it goes into all the essential knowledge associated with it, and I think we're going to do a pretty good job of summarizing that over the next couple minutes here as I go through it. So what is K-selected and what is R-selected? Well, what they are is they are reproductive strategies. So this is the way in which an organism reproduces, and it's really linked to population growth and population rebounding, and then that actually links into a lot of other ecological concepts. So the one thing that we have to remember is that humans will reproduce year-round. Why are we able to reproduce year-round? Because we've modified our environment to the point where we can now produce food year-round. If you go to the grocery store, you can find peppers and tomatoes year-round because they're grown in greenhouses in different areas and flown in because we live in a globalized society. That food abundance allows us to be able to get nutritional values, which then we can continue to use and continue to grow our populations. We don't have a season where we struggle to survive. Everything actually is available to us at all times, and that allows us to do well and reproduce at any time. 90% of the planet's animals and whatnot, and even plants, do not follow that protocol. They are reliant upon abundances of food, safety, different other factors that go into when they are able to reproduce and why they reproduce at those times. K-selected and R-selected, again, is a reproductive strategy. And what we're really looking at is how frequently do you have offspring and how much parental care do you put into raising those offspring. Humans, for example, when you reproduce as a human, most of the time it's one offspring, but yes, you can have 2, 3, or more. But for the most part, it's a single birth at a time. We then spend a lot of energy raising that baby or that infant to an adult size, and then we focus in on that, and we're not reproducing like 3-4 times a year. It doesn't work that way. There are other organisms which will produce thousands upon thousands of offspring at one time with no parental care. It's just kind of a good luck, and maybe I'll see you at adulthood situation. And those two different things really make up the basis of the R strategist versus K strategist. In this picture here, you can see like kind of the idea that this is not just one or the other, okay? It is not like you are either R strategist or you are either K strategist. It is oftentimes a spectrum, and organisms fall somewhere into that spectrum depending on the amount of offspring. Now, what I will often say is, even looking at this picture, I'd probably draw the line of the rabbit and going to the left as the organisms that are R selected, or normally we classified as R selected. Usually, if you're only producing 1 to 2 offspring a year, you're more off to the K selected side. Now, what is this really based on? And this is based on something called biotic potential. And what we're really looking at is how fast can a population grow. The biotic potential is the absolute fastest rate a population can grow if all limiting factors are available. You have enough food, you have enough water, you have all of those things. You live within that tolerance zone where you can focus in on reproduction because you know you are safe in all the other categories. That is how we can measure our true biotic potential. Biotic potential is often represented with an exponential growth curve, or what we would commonly refer to as a J curve. All right, and what happens is it means that as you're reproducing at a fixed rate, so this is actually a fixed rate, it's just like a percentage, you know, maybe it's 2, 3%, maybe it's 10%, who knows what the rate is. All right, it will just continue to go up. Now, the thing is, we're going to eventually learn about the idea that an ecosystem has a limit to how fast a population can grow, and it's going to start to slow that down. So let's get started. First off, talking about K-selected species. The K in K-selected species is in reference to carrying capacity, which we're going to talk about in 3.4. Now, I know what many of you are saying. Carrying capacity doesn't start with a K. What I believe it to be derived from is a German word. Germans really did a lot of the initial research and have a lot of the initial ecological theories established. So a lot of zoology, a lot of ecology is based off of German science. When you learned about the cell theory, you learned about two very famous German scientists, Theodor Schwann and Matthias Schleiden, who identified that all plants and all animals are made of cells. So that's where the K in K-selected. So just try to remember K is carrying capacity, because these organisms, their populations usually exist at the carrying capacity for the ecosystem. Therefore, they're not going to need to have massive population growth or rapid population growth because they're already at their max population for that ecosystem. What are some general characteristics? Again, these apply to that spectrum. If you hit most of these criteria, you're probably a K-selected species. Are you usually a larger organism? Okay, most of our small organisms reproduce very, very rapidly. But some of our small organisms do take some time. But for the most part, we're saying larger organism, like, I don't know, bigger than rabbits, bigger than squirrels, but smaller than, there's also organisms smaller than humans that are K-selected species. Do you have few offspring per reproductive event? So meaning a small brood size or litter size. If you are only producing 1 to 2 offspring at a time versus thousands or even 10 to 15 with some animals. Different types of organisms produce different amounts of offspring at a single litter. Do you have a long gestational period? Elephants, their gestational period is about 18 months. Humans, we know, is about 9 months. It's how long are they in the womb. If you have a short gestational period, you're able to produce multiple broods per season. So some birds, like robins and different other things that you'll see during the summer around here, they might have 2 to 3 sets of offspring a year, just because they're able to produce that first one early. Then they raise them, hopefully they fledge the nest, and then they'll go and try to reproduce again if food is available, if all those limiting reactants are available. Now, that's not the same as humans, which again, you can't have 2 offspring in a calendar year. Yes, I know you can in theory, but for the most part, we don't. High energy involvement or investment in raising the young, so they mature in a long period of time. Every year, I get questions always asked about, what is this? Oh, it's a small bird outside flying around, so it has to be a baby. Birds, in order for them to leave the nest, are fully grown. So when birds leave the nest, they are fully grown. So it's not like you see a bird in flight or a hawk in flight and say, oh, that's a baby, one of these. No, that never happens. It might be a young or an immature because it hasn't developed its full adult plumage or feathers yet. But the idea of it being a baby is not the case. So it's not like you see a baby eagle in flight. No, when eagles take flight, they're fully grown. Now, humans, for example, we have to raise our young. We have to raise our young. It's not like anyone's just, 4 months of being raised and then all of a sudden you're on your own. No, it doesn't work that way. And there's a lot of other organisms which spend an immense amount of energy raising their young, protecting them, making sure they reach their own adulthood or maturity levels. What's the life expectancy of the organism? The life expectancy is quite long. It's probably a K-selected species. It's pretty sure it's probably going to be an R-selected species. And then K-selected species are often predator species, but there are a lot of exceptions to this. Things like elephants are not predators. You're not going to see an elephant hunting down different animals. But the idea that a lot of our predators can fall into the K-selected species more than the R-selected species category. It's just more of an observational stat. I don't really know the true data on that one. So let's compare some of our examples here. Obviously, things like the gorilla, the silverback, or mountain gorillas, they take a very long time to have offspring. They make sure the conditions are proper. Kangaroos, elephants, hippos, but that's also why their populations don't rebound very, very rapidly. And over here on the right-hand side, you can see a list of different organisms and their gestational periods. So how long are they actually in the womb or in utero? And you can see different things from elephant at 645 days to things like seals at 330 days, so almost a year for seals to have an offspring. Various organisms have different gestational periods. Now let's go to the converse. Let's go talk about some of our R-selected species. I'm going to go through this a little bit more faster because we just kind of talked about the K. The R is pretty much...
Okay, I'm going to pause it there and we'll do R tomorrow because we got 1 minute left to class. But I hope you were paying attention. I noticed some of y'all didn't pay attention that much to the last one, so that's why you kind of went back and forth with the quiz. But I hope you're paying attention because you do need to know the difference between these different types of species. So we will finish looking at this one tomorrow, and I will go over those questions from the quiz, and then maybe Friday we'll redo the first one and then take the second one on Friday. So I will go over the one you just took, and then we'll revisit it again on Friday, in addition to doing the R and K species quiz. Okay? All right, you all have a good afternoon and see you tomorrow.